Okay, so for this video, we'll be doing the solution for J7, which is in your dynamic notes. Okay, let's read the question. P, Q, and R are three blocks resting on a smooth surface. Whenever you see smooth, that means there's no friction. Alright. A force of 30 Newton is applied at one end as shown in the diagram below. Given that the masses of P, Q, and R are 1 kg, 2 kg, and 3 kg respectively, what are the tensions T1 between blocks P and Q and T2 between blocks Q and R in a string? Okay, to solve this question, we need to firstly treat P, Q, and R as one body. So their combined mass will be 1 plus 2 plus 3, so it's equals to 6 kg. Okay, so this is equivalent to the 30 Newton pulling P, Q, and R, right? So now I have this body PQR as a 6 kg mass, and now this is pulled by a force of 30 Newton. And since the question says it is on a smooth surface, the 30 Newton will now be the F net for this combined mass of body of 6 kg. Then we apply the formula F net equals to MA. So since our F net is 30 Newton, there's no friction, only a pulling force of 30 Newton. The combined mass is 6 kg. We can find the acceleration of 5 meter per second square. That means P, Q, and R will all be experiencing this acceleration of 5 meter per second square, right? So why is that so? Imagine you're in an MRT train and the train is being pulled by a certain force, right? Will all the train carriages be moving with the same acceleration? It must be, right? If not, it cannot be that the larger mass has larger acceleration, so on and so forth. If not, then the carriages will actually crash into one another. So that's why we combine the whole total mass of these three objects into one, so as to find their common acceleration. So after we have combined them, we have to split them up. So for P, it is now 1 kg, right? And it is only pulled by a force called T1. Now we know what is the acceleration of P, which is 5 meter per second square. Whenever there's an acceleration, there's going to be a F net. In this case, for P, the mass is 1 kg, the acceleration is 5, so F net will be 5 Newton. That means T1 is equal to 5 Newton. Okay, let's do for Q. For Q, again, we draw the free body diagram. We are interested in all the forces acting on Q. Q's mass is 2 kg. There is a pulling force of T2, and there is also a pulling force of T1, right? Because Q pulls P with a force of 5 Newton, P will pull Q with a force of 5 Newton due to Newton's third law. So this is going to be 5 Newton. T2, I don't know how much it is, but I know that the acceleration of A is 5 meter per second square. Yes, they all should have the same acceleration. So let's put it into the formula again. F net equals to MA. F net I'm not sure now, but I have the mass is 2, acceleration is 5, so the F net is going to be 10 Newton. So how do we represent F net? We draw it above the diagram, above the body, not touching the body, with a double arrow. So let's analyze this. T2 and T1 are in opposite direction, but the resultant force, or F net, is towards the right in the direction of T2 with a size of 10 Newton. Therefore, T2 minus T1 should be equals to 10 Newton. And T2 is actually the value that we want to find. T1 is 5 Newton equals to 10 Newton, and therefore T2 must be equal to 15 Newton. Okay, so that is the answer. T1 is 5 Newton, T2 is 15 Newton. But let us do a check with R. So let us do R. Okay, R has a mass of 3 kg. What are the forces acting on R? That is what we are doing here, a free body diagram for R. There is a pulling force of 30 Newton. Okay, it is in direct contact with this 30 Newton, and there is a force of T2. So again, what is T2? T2 is the force that the 2 kg mass, which is Q, is exerting on R. So R is exerting a equal and opposite force of T2 on Q. Q pulls R, R pulls Q. This is Newton's third law. Okay, so T2 should have a force of 15 Newton, and I have a pulling force of 30 Newton. So the resultant force is 15 Newton, right? So if my 15 Newton, my F net is correct, it should correspond to the formula. So my F net on the left hand side is 15 Newton. Now, what is the mass of R? It is 3 kg. What is acceleration of R? It is 5. So I will get 15 here, I get 15 here, and they are equal to one another. That means all the forces are correct and accounted for.